Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0453, indicates a high voltage reading from the fuel tank pressure, FTP, sensor. This issue arises within the evaporative emission control system, primarily responsible for capturing and containing fuel vapors that escape the fuel tank. The FTP sensor itself is typically located near the fuel tank and monitors the pressure within, aiding in proper engine function and emissions control. If the FTP sensor sends back a voltage signal that is too high, it may signal that the system is experiencing a malfunction. Diagnosing and resolving this issue is crucial for adhering to emissions regulations and ensuring optimal vehicle performance. Various troubleshooting steps can help identify the root cause of this high voltage reading. The FTP sensor measures the fuel vapor pressure within the fuel tank. It's crucial to the evaporative emission system as it helps ensure that unburned fuel vapors do not enter the atmosphere. The sensor is typically mounted on the fuel tank or along the fuel lines, and it translates pressure changes into a voltage signal for the engine control module, ECM. A high voltage reading from the FTP sensor, which is what this DTC indicates, could suggest an electrical fault or a sensor malfunction. When troubleshooting, it's vital to consider the wiring and connections leading to the sensor to rule out simple issues like shorts or opens. By correctly identifying the problem, mechanics can address it effectively and restore the vehicle's systems. Multiple factors could lead to the P0453 DTC. First, a faulty FTP sensor could directly cause the high voltage signal being registered. Sensors can fail due to wear and tear, impact damage, or internal faults. Second, poor connections at the FTP sensor or the engine control module, ECM, can lead to erratic signals, causing incorrect readings. Finally, wiring issues such as shorts, opens, or corrosion can also impact the sensor's ability to function and signal appropriately. Addressing each of these potential causes methodically is essential to effectively diagnosing the issue and ensuring system integrity. If troubleshooting reveals no fault in the sensor itself, it's essential to inspect the connections and wiring leading back to the ECM. Symptoms associated with DTC P0453 can include the activation of the check engine light, which alerts the driver to potential issues with the vehicle's emission system. You may also experience a drop in engine performance, as the engine may alter fuel-to-air ratios based on misleading information from the faulty sensor. This can lead to rough idling or stalling. Additionally, if the vehicle is subjected to an emissions test, the presence of this DTC will typically result in a failure of the test, reflecting regulatory compliance issues. Recognizing these symptoms early can promote timely diagnostics and repairs, preventing additional issues or costly penalties related to emissions control violations. It's essential to monitor the DTC codes and act swiftly to mitigate potential problems. Begin by turning the ignition switch to on/2, ensuring the vehicle electronics are operational without starting the engine. Next, utilize the Honda Diagnostic System, HDS, to clear any stored DTCs. This step helps in resetting the monitoring system to obtain accurate data in subsequent tests. After clearing, check the FTP sensor data in the HDS data list. You're looking for a reading around 7.3 kilopascal, 2.16 inches, or 55 millimeters inches, or a voltage of 4.7 volts or more. If the indicated reading aligns within these parameters, continue troubleshooting with Step 3. However, if the values are outside this range, proceed to Step 2 to verify any issues with the system's other components. This step involves verifying the issue by starting the engine and maintaining a speed of 3,000 revolutions per minute, RPM, while in neutral. Continue this until the radiator fan activates, then allow the engine to idle. During this process, monitor the onboard diagnostics OBD status using the HDS. If it indicates a failed status for DTC P0453 and the fault was not replicated and likely temporary, thus moving ahead will take you to step 3 for further checks. If the status reads passed, the symptoms might indicate an intermittent failure, suggesting other areas such as poor connections or loose terminals at the FTP sensor and the ECM should be inspected. If the HDS shows not completed, keep the engine idling until complete data is accessible. In this step, disconnect the FTP sensor's 3-pin connector to isolate the sensor from the circuitry. You'll then create a jumper wire connection between terminals A and B of the FTP sensor connector. Terminal A refers to the white wire, while terminal B corresponds to the black wire. Next, turn the ignition switch to on, 2, without starting the engine, and check the FTP sensor data once more using the HDS. If the readings reflect around 7.3 kilopascal, 2.16 inch in Hege, or 55 mmH, or at least 4.7 volts, this indicates that the system is proceeding correctly, moving you to step 4. If it shows otherwise, it signals that the FTP sensor is faulty and replacement becomes necessary before proceeding to repair verification. Here you'll measure the voltage level between 2 specified test points while the FTP sensor's connector is disconnected. The critical voltage check occurs between the red wire at terminal 1 and the black wire at terminal 3 of the FTP sensor connector. This measurement should ideally be around 5.0 volts with the ignition in the on position. If you verify that you have this desired voltage, seamlessly move ahead to step 5 to check for wire integrity of the P-tank line. However, should the voltage fall outside of this target, you will proceed instead to step 6, indicating potential wiring issues with the system that require immediate attention. Begin this step by turning your ignition switch back to lock, 0. It's advisable to jump the SCS line with HDS for safety. Disconnect the ECM connector A, 49P, and utilize a jumper wire to connect solder points on the FTP sensor 3-pin connector. Specifically, connect terminal 2, white, temporarily to body ground. Check the continuity between test point 1, ECM connector A pin 37, white, and body ground. This will confirm the integrity of the P-tank wire. If continuity exists, that indicates the wire is functioning correctly. If continuity does not exist, a break in the P-tank wire between the ECM and the FTP sensor needs to be repaired, followed by a repair verification to ensure integrity is restored. As with the previous step, start by returning the ignition switch to the lock position and jump the SCS line with HDS for electrical safety. Disconnect the ECM connector A, 49P, next, and again utilize a jumper wire to create a connection between the FTP sensor connector terminal 3, blackout P, and body ground. In addition, check for continuity between test point 1, ECM connector A pin 10, black, and body ground. Assuming continuity exists, it would imply that your SG6 wire is functioning correctly. If continuity fails to appear, inspect and repair any breaks in the SG6 wire leading back to the FTP sensor, ensuring proper functionality before securing all connections and moving forward to repair verification. In this final verification stage, begin by securely reconnecting all previously disconnected connectors to ensure proper communication across the system. Next, utilize the HDS to reset the engine control module, ECM. Resetting helps refresh the system parameters and learn any new configurations or repairs made. Following the reset, you will perform the ECM idle learn procedure. Then, start the engine, allowing it to idle while you continuously monitor the OBD status for DTC P0453 using HDS. If the results indicate passed, the diagnostic process is complete. If the ECM was changed, switch back to the original unit. Should the result display failed, revisit the previous troubleshooting steps to ensure accuracy and address issues accordingly. To maintain the integrity of your vehicle's evaporative emission system and prevent issues like DTC P0453 from emerging in the future, regular preventive maintenance becomes essential. Regular inspections of wiring and connectors can identify and mitigate issues such as wear, corrosion, or physical damage before they escalate. Checking connectors specifically for signs of corrosion is crucial, as degrading connections can lead to sensor failure and subsequent DTCs. In addition, addressing any faulty components promptly ensures that the system can operate effectively, maintaining both performance and compliance with emissions regulations. Establishing a maintenance schedule can greatly improve the longevity of the vehicle's emissions system, providing peace of mind for the owner. In conclusion, understanding the role of the FTP sensor is critical in diagnosing and resolving DTC P0453, which indicates a high voltage reading. By following a systematic troubleshooting approach, you can accurately diagnose the issue, be it a faulty sensor, wiring, or connection problem. Each step offers a clear path to identifying and correcting faults, emphasizing the importance of each component in the vehicle's emissions system. Furthermore, performing regular maintenance can help avoid such DTCs in the future, ensuring that your vehicle remains compliant with emission standards and operates effectively. Ultimately, knowledge, attention to detail, and preventive action contribute substantially to vehicle longevity and performance. Please like and subscribe to the channel. See you next time.